o'clock in the morning. And thanks a lot for joining this webinar. And this is a new product, and we plan to release very soon. And we are very happy to invite our Deputy CEO, Dr. David Xu, and he will present us this material hub and let us know how we can benefit from this product. Okay, so David.
Yes.
Okay,
It's
and
my
this
turn.
is your time, please.
Okay. Hello. Good morning, everyone. I'm David. In this sections, I will present you the basic idea of the Material Hub Cloud Service, and of course, first I will recap you about the importance of the material characterizations. Because I know most of you already sell Moldex3D many years. But usually we regarding the material characterization as a bundle or as an extra service attached with Moldex3D. But I think it's still a very good business in the future. So in the first presentations, I will show you why and how the material is tested in Cortec. And next, I will give you a very brief introduction about the idea and the business opportunities for the Material Hub Cloud Service. And after my present, Dr. Bruce will give you an in-depth presentation about how to use the Material Hub Cloud. I think soon you will get some trial license and you can try by yourself. But I think a very brief training is still needed before you try by yourself. Okay, so I will start my presentation now. Okay, why plastic material is important? I think plastic material is the core for polymer processing. Why? Because if we check a typical injection molding process, of course, you will see many important factors can influence the molding qualities or the productivity. We were talking about material. We are talking about the mold part design. We are talking about the injection molding machine and the molding process. So as I think as you can see in these years, Moldex3D, the major research and the development direction is how to build the digital twins for the 4 parts, how to build a digital twin for material, for design, for machine, and for process itself. And the material plays a very key important factors. Because usually the reason we choose specific plastic material for the molding is based on its performance. This means mechanical property usually is the first properties we need to check before we select it as a molding material. So usually we will based on this kind of the chart. Okay, we will check its Young's modules, we will check its density. Okay, and we select polymer. Okay, is our molding material because it has a better moldability, or it is lighter, or it's cheaper. Okay, and once we choose the material, then its mechanical curve is the second things we need to consider, because we want to the molded parts can have enough strength, can be applied in different environment and different scenario. So we need to check its strength curve. So usually mechanical property is a key for the part materials selections. So in our material hub, we also focus on this kind of the applications. I think this is slightly different from the Moldex application, because in past Moldex is more oriented in the molding. However, if we want to penetrate into the design market, we should consider the mechanical property, or we should change our mind for the properties. We should focus more on the mechanical property first. And the second is about the processing properties. I think this is a typical properties everybody knows in our business, how to persuade user why viscosity, thermal properties is so critical for the molding, because it's determine the molding behavior and the production stabilities. Many molding defects, such as the short flash or the hesitation flow or flow mark, are highly related to the processing properties. So usually in the product design workflow, we choose the material based on its mechanical properties response. Then we want to design our mold, want to specify our process conditions, help this can improve the moldabilities or improve the processing properties or the processing windows of the selected mold and the material. And of course, accurate material property is very critical for the simulation. Okay, so this is all the cases. Okay, this is the connector, and this is the short experiment. If the viscosity data is not good, we cannot get good simulation result. However, if the simulation data, if the material data is good, then we can get a very good prediction result in compare with the short experiment. So I think everybody know about this, and this is very important to our customers. So sometimes customers want to check the feeding patterns, they want to check in the warpage, but usually he just did not measure the data. He just using some default values, or he just using some alternative material properties, and hopefully this can get a very good or very accurate prediction result. So I have to say this is a misunderstanding about the situations. So okay, so as you see in the CA simulations, we solve lots of the equations, and many of them involve the different properties of the plastics. Among them, these are most important one, including viscosity related to the feeding behavior, PVT related to the packing behavior, and the shrinkage warpage. Thermal properties such as heat capacity, thermal conductivity related to the heating cooling behavior, also related to cycle time. And the mechanical properties related to the path strength and the mechanical behavior, shrinkage and warpage. Okay, so why the polymer plastic is so complicated? Because it is there is a very big diversity for the materials. Now in Moldex3D we have nearly 7,000 different material in the database, and in the market there will around I think more than 10,000 or even more grade available in the market, and the different polymers according to their microstructures, they can be thermoplastic, they can be thermoset, and according to the degree of the networking, also we have some slightly networking materials such as PU, PUR, and rubber, and there are some strong, highly connected network structures. They're related to the epoxy. Is very common for the semiconductor industry, and for the thermoplastic, according to their microstructure, we can divide it into amorphous and crystalline. And of course, different microstructures can lead to their different properties. So the properties of the polymer also highly microstructure dependent. This is not only related to their degree of the polymerization, because we know polymer is a chain-like material, so the length of the chain is very critical to its properties. Also, molecular weight distributions, morphologies, distributions is also very critical to their properties. Of course, the properties are nonlinear, And the other is the properties are highly process variable dependent. For example, viscosity may highly depending on shear rate, temperature. So usually our users, they want to know the flow behavior, but they just have an MFI value. Okay, everybody know MFI value is a single point value. You got this data by a single point testing. However, the properties of the polymers, depending on temperature, depending on shear rate, depending on several different process conditions. So if you want to get a very good understanding of the molding behavior, or you want to get a very accurate simulation result, you need to consider this kind of the process dependency. So this is answer why we need to do the intensive material testings before we run in the molding simulations. And of course, phase change involved in the molding. We need to melt. We need to melt in the plastics, inject it into the mold, and after the mold shaped, the parts we cool down and eject the mold. So it will involve melting and solidifications. Use of filler, use of the recycled material, and in some cases, the polymer itself is a multi-phase polymer systems, or it is involved some polyblend. So it will got more than one single polymers in polymer systems. So this will make the polymer properties even more complicated than the traditional materials such as the metal or the organic materials. So to handle this, Moldex3D has invested several years and invest much monies to build our material calibration and research centers. And this center already get the certifications from the ISO to ensure our measurement procedure and the documentations satisfy the requirement for the ISO certification. And we have already introduced many different instruments for the measurement. Okay, here just give you the show list of the instrument available, and except the traditional thermoplastic measurement, we also have some special instrument for special molding, such as the format. This is the instrument for the PU or the PU chemical forming kinetics measurement. We have the easy perm. This is for the resin transfer molding to measure the permeabilities of the molding compounds in the fiber mate. And this year we introduced Cross DSA 100. This is the equipment to measure the contact angle. This property is important for the underfield process in the semiconductor industry. This is important. So we measure this to get the surface tension of the materials. So first, the important property is shear viscosity. So usually we use in the capillary rheometer to get the shear viscosities. And this kind of the measurement is validated for high shear rate. So usually the shear rate is higher than 100. So for the low shear rate, we need a different instrument. For a low shear rate range, we use in the rotatory viscometers from Anton Par, and this kind of the measurement we can get the low shear rate. So if you want to get how the viscosity change with the shear rate at the low and high shear rate, we need to do these two kinds of the measurement and to combine the measurement data for the fitting. And all you know, viscosity is very critical to the flow resistance of the melt in the cavities, and also strong influence on the feeding behavior. I think most of Moldex3D application, I think it may be not more than 80% is to solve the feeding problems. So it's highly related to the viscosity measurement. And of course, if the material is a thermoset material or the IC encapsulant material, such as the epoxy molding compound, in this kind of material, the chemical reaction or a curing reaction will happen. So the polymer properties will change from the monomer to the cured state or the polymerization state. So when this happens, the viscosity will change dramatically. Okay, so when we molding this kind of the material, we need to check this data, and we want the feeding stage happen in this area because the viscosity is low. Once the viscosity increase, then there will be some molding defects such as the short shot. Also, so we need to very precisely to control the feeding patterns at the low temperature area. Of course, this is also related to the curing kinetics. So this kind of the properties, they need to combine the measurement of the curing or reaction kinetics with the viscosity data. So we combine these two kinds of the viscosity data, and the data is related to the chemical reactions. So this is why we call it the chemorheology, because the rheology is related to the chemical reaction. And of course, this kind of the measurement is related to the molding of the thermoset material. Okay, the most important one is in the semiconductor or the electric packaging process, such as the traditional transfer molding or the more advanced under-fill molding. This is based on the capillary force to fill the cavities. And in some wire bond product, the wire will be dragged or even destroyed by the molding compound. We call it the wire sweep effect. So this is also highly related to the viscosity variation of the epoxy molding compound. So the chemorheology is key to the semiconductor or the electronic packaging process. And the second important property is in the PVT. Okay, usually we measure the equation of state to describe the relation with the specific volume versus temperature and the pressure. Okay, and as you know, because the microstructure or the morphology difference, the semiconductor, semi-crystalline polymer or the amorphous polymer, they have a different behavior from a PVD curve. And this also related to the shrinkage and warpage control. So usually based on this data, we can control the process conditions to help us to reduce the warpage behavior. So this is also important for the warpage control. And of course, if we are talking about a thermoset material, we need to consider the extra factors, the conversions, C, okay? This is alpha here. And in Moldex, we also have we self-developed instrument to measure this kind of the data. And this kind of the data is important, again, for the package, or we call it the strip deformations, and also related to the annealing process control for the same in the semiconductor industry. Okay, DSC, okay, I think it's used for the reaction curing kinetics, crystallization kinetics measurement. Thermal property measurement, okay, we are talking about thermal conductivity and the heat capacities. And right now in the 5G applications, because of the 5G, usually we were talking about high frequency applications. So how the heat generated by the high frequency applications can be dissipated into the air or can be removed quickly is very critical. So the thermal conductivity of the 5G applications is important, even for the polymer. Okay, and the next is about the mechanical properties. Now in our laboratory, we have the instrument machine, so we can measure the strain stress curve at different temperature. Okay, now we already measure many data for different plastic material. So usually from this curve, you can check the ease of deformation of the specific material. For the elastomer material, usually we have this curve. Okay, we can elongate this material very long without increase the stress. And for the brittle material or hard material, the curve is like this one. Plastic is in between. Okay, so we can check. This is the curve for the PP, and this is curve for the SEBS. This is the elastomers, and this is the curve for the polyimide. Okay, so in this way, we can check the different response of the plastic material. And in past, usually in the simulations, we only focus on the linear area. So usually in the model simulations, we are just talking about the Young's modules and the Poisson ratio. However, this kind of the curve is very important for the design of the parts. So I think this kind of the measurement will get more and more important in the future. And for the fiber reinforced plastic material or the composite, we also can check the influence of the fiber orientations on this kind of the curve. This is the experimental data conducted by ourselves. So we have a molding center, so we can have this kind of the testing plate, and we can cut the testing plate in 3 directions. For the A directions, because flow is in these directions, so A is parallel to the flow directions. So we can see most of fiber orientation will align with the flow directions. Okay, flow in these directions. So fiber will align with the flow directions. So the strength will be very strong in this direction. So this is why we got this curve here. And if we cut in the perpendicular directions here, C is in perpendicular with the flow directions. So it is in parallel. So this directions is in parallel with the flow. So you will get a very poor mechanical strength. We got C curve here, and if we cut the space in 45 degree, and to do the test, you will get curve in this way. And it's very funny if we check the final break point. These 2 break points, they are perpendicular, and this you will see a break shape is around 45 degree. This is reflect the fiber orientation. Okay, so it's critical for the fiber orientations. So this kind of the measurement now also can be conducted in Moldex3D, and based on this data, we can map this kind of the measurement to the micromechanics modeling of the simulation. Okay, last one is about viscoelasticity. Now in our laboratory, we can measure the viscoelasticity in the solid state, also in the fluid state, and we need different machine and to superimpose the measurement data together to get the master curve. And this kind of the simulation, this kind of the data is important for the transparent plastic lens or the optical components applications, because in this kind of applications, usually the optical performance or the photoelasticity or the biofrequency distribution is very critical for this kind of the applications. So based on the viscoelasticity data measurement, we can run in the simulations and run in our biofrequency simulation modules. We can predict this kind of the biofrequency. Okay, so this is very important to this kind of the applications. So this is one of the major application of the viscoelasticity, especially in the CAE application. And also this phenomena also related to the high residual stress and the painting issues. Usually for the parts, for the non-transparent parts in some area, because the high residual stress, so there will be some painting issue. The painting is very difficult to have the smooth surface for the high stress area. So by this kind of the simulations in combined with the viscoelasticity measurement, we also can make this kind of the predictions. And of course, viscoelasticity also related to the flow instabilities and some jettings or snake-like flow, tiger strap. This kind of the phenomena also highly related to the viscoelasticity of the material. Okay, so above is right now in Moldex3D, basically we can make lots of the measurement for the thermoplastic and the thermoset. And also in the laboratory, we are working on to create the plastic material digital twin. Okay, this will give you a simple idea about what this stands for. For example, this is the capillary viscometer, and we call it the physical twins of the instrument. And we can create a digital copy of the machine. So we can create the structure like this one according to the structures of the viscometer, and we can run in the simulations. And it's interesting when we run in the simulations, we can check the shear rate, we can check the temperature, and we will find for this kind of the measurement, usually we assume the temperature is at a specific temperature. For example, 230 degrees C. However, due to the viscosity heating happen in the flow, so the temperature will increase. So in reality, your measurement data temperature is not your specified data. So by this kind of the simulations, we can go back to correct the data. Okay, so of course, temperature is just one of the corrections. The second is about the shear rate, and when we are talking about the Buckley flow, because there may be some vorticity here, so we can also include in the viscoelasticity calculation here, and to calculate the Buckley correction. This is an underworking project. So basically, based on this kind of the simulations, we can use in this data to correct our measurement data. So you can see the blue one is the original measured viscosity. After the corrections, we will see some shift of the viscosity curve. And we can also compare the prediction of the two material data. This curve is exported from the instrument. So we can measure the pressure at a different ramp position. The ramp position stands for our setup of a different shear rate. Okay, you can think in this as a shear rate. So at a different shear rate, we got different pressure, and the original data prediction will be here. After the corrections, we can get a better predictions for the pressure. So we call it the DT corrected data. So we also conduct this idea to different material such as ABS, HIPS. We will get a better result once we do this kind of the digital twin corrections, HDP, PP, and we find if the viscosity of the material is critical, then this kind of the heating is more significant than the typical materials. Okay, so the idea of the digital twin is we, based on the original physical twin, we measure the data and we run a digital twin, and we can come back to correct the material data and make the data more corrected for the pressure predictions. And hopefully this also can make a better predictions for the flow predictions and the pressure predictions. Okay, and we also working on the other viscometers such as the rotational viscometer. Okay, right now we already checked the temperature. Next step is to check in the flow. And also PVT, we check in the output of the temperature compared with the simulations. So this also can go back to correct the PVT measurement. And also for format, we measure the growth of the strength of the experiment. For the easy perm, we also can check the feeding time with the digital twin, and this can go back to correct the permeability measurement. So in one word, this is not only useful to improve the predictions, they also can help us to develop the new machine. Now we are developing many new measurement instruments based on the digital twin concept. Okay, so above is about the capabilities of our measurement, and we also have a molding research center can do the material molding validations. Now we have two major molding machine. One is the thermoplastic from upper injection molding machine is 250 ton, so we can run in the bigger testing plate, and the other is from bottom field for the LSR molding. This is our next stage research projects for the LSR material. Okay, so for the upper injection molding machine, we equip it with a very high precision mold and lots of the sensor, so we can check in the feeding pattern, we can check in the shrinkage of the parts, and we can check in the prediction of the pressure in the nozzle, also in the sensor node inside the cavities. So in this way, we can validate the correctness of the material data and the material model parameters. Okay, so here is a short remark for the material characterizations. First, polymer processing core is plastic material because it is our objective for the molding. Okay, so mold and machine, they are just tools. So how to get the key understanding of the plastic material is key success factors to design and manufacturing. And now Moldex3D offer a very completely material characterization service packages. So now we already have the standard package. You can get this test from our sales representative. And we have the standard package, and also we have the customized packages. Right now in our material characterization centers, we can measure around 300 material per year. This is our measurement record in the last 3 years, and this years we already increased the capacities. So we expect this year we can expand the characterizations amount from 300 to 60 and to 600. And our goal is we can measure around 1,000 material per year. So now we continue to expand our investment in the major instrument and the capacity of the material characterizations. And of course, it is a good business because right now in Moldex, from the income from the material characterizations is around $1 million per year. And once we expand the capacities, we can expand the business to 2 million or even $3 million per year. So I think this also can be an extra service we can provide to our customers. So you can also sell this kind of the material characterization service to the customers even by a standalone basis or by a bundle sale basis. Who needs this kinds of the service? Material data not available in Moldex3D. I think most of the users, maybe they just want to run some specific material, but right now it's not available in Moldex3D. Then you can persuade him to using this kind of the service, or you can bundle this service with your sales. Okay, this is what I mean for the bundle sales for the Moldex3D users. Also, new developed materials, or the material users compounding by themselves. And the last one is about new material development. Some material suppliers, they want to compare the processing properties or the details, basically the elasticity response of their new material with the competitor materials. Then we can also offer users this kind of service to make the detailed comparisons of the materials. So this is a very short remark about the material characterizations. And the next is about, I think is the major topic of today's present for the Material Hub Cloud Service. Okay, so for the Material Hub Cloud Service, we will offer the basic subscriptions in June 15, this month. In June 15, we will start to offer this kind of the basic subscriptions. It is basically is a web service. Okay, and focus on the part designer and the CA specialist. So it's a very simple design. You just have the account, password, and you can log in, or you can try by yourself by the training account, and then you can try the service offer here. right now in the first release, we have 3 major functions. First one is a material data viewer. Second is alternative material search. The last one is a material selection guidance. And for the material data viewer, basically this cloud service share the database for the standalone Moldex3D at this moment. But I think in the future we'll make the database slightly different from the Moldex. I will explain this later. And in this database, we will check around 6,800 different material right now in Moldex database. And we will give you an index about a material quality index. So if you open specific material, we will show you the quality index analysis here. We will show you some key processing curve here and the mechanical property here. And at the different page, you can also check the detailed curve of the materials. Okay, so we can check the key processing parameters at a different temperature. I think Bruce will give you more in-depth introducing later. Okay, so you also can check a different curve. So right now, basically, this data viewer is an extension of the current Moldex3D database. We hope in the future we can provide more and more different viewer tools or the check-in tools to help users to utilize this database not only for the simulation purpose, but also can use this kind of the data in their design stage. And the second key function is about alternative material search. Okay, usually right now in Moldex3D, if users they want to run in the simulations, but they cannot find a material in the database, they have the two choices. First one is they measure the data, but it's cost intensive and it's a time consumptions. And the second choice is you pick up alternative material for the simulations. So in past, usually we provide this kind of the suggestions to our users, to our potential customers manually. Okay, and the manual is based on his experience, or I have to say is his institutions. However, we developed this tool. This tool is based on the scientific comparisons. So all you have to do is to input the key properties, the key criteria properties of your target material. The material usually is not, it cannot be found in our database. So you just input the key parameters such as the MFI, density, melting temperatures, something like that. You can specify the comparison criteria, and you also can assign the weightings of the criteria. So then based on these weightings, we can give you a list of the alternative materials. So not only give you a candidate alternative material, we give you a list, and we rank the list according to the similarities of the candidate material to your target materials. Okay, so this is the basic idea of this material. And of course, here give you an example. For example, we choose a material here, and we based on the functions, we can choose 3 different material according to this is highly similar to the original material. So the similarity is 93. And this is second alternative material. This is third alternative material. The similarity is only 65, and the key difference in the amplified value. So of course, the feeding pattern you cannot check a big difference because in this part is sequence is uniform, and you will see the difference for the curve. Okay, for the especially for the injection molding curve. Okay, so for the similar material, their curve is similar. However, for material, the MFI is difference is big. You will see a poor prediction of pressure here. And of course, we will, if you want to get a good predictions, you measure the data. But however, in some cases, you just have no time, no money to do the measurement, or you just want to do some very quick checking of the material. You can using these functions help you to identify the better alternative material for the simulations. So this give you a example here. And the second example, we focusing on the warpage analysis. So for the warpage density, CT is a key parameters. Okay, so again, we choosing the very similar, not so similar, or dissimilar material, and we compare the fitting pattern quite similar because the pi is so simple. And the warpage, you will see the warpage behavior will be quite different. Okay, so according to your requirement, you can specify different criteria for the comparison. So usually for the fitting analysis, MFI is the most important one, and the other is the optional. For the warpage, density CTE is the most critical one. Of course, MFI should be as similar as possible. And of course, you can choose more data for the comparisons. Okay, so this function give you a tool. You can specify, you can choose the alternative material according to the criteria you selected. And this, I think this can solve most of the problems from our users. They want to SEU, they want the alternative material, and we have no answer in our database. I think this is one of the key applications. And the second application is in some cases, you just want to search the alternative material, not only for the CA simulation. You just want to find some substitution material. Then you also can use in these functions and choose different criteria, help you to check the substitution material for your target material. Okay, so here just give you a short list about potential competitors in the market to our web service. ANSYS Granta, it is a standalone database. The basic modules is around $6,000 US, and for the advanced package, you will depending on your package. It is a standalone product. Digimet and Airtel, they are more focused on the inorganic properties. Embase and Campus, they are more focused on the polymer. Campus is free, and ESA is mainly polymer. Embase, they will charge the subscription fee is 390 euro per year. However, the problem is in their database, most of them are mechanical properties. Only very limited curve data, such as the viscosity, such as the PVD, is available. So I think this is the competitive advantage of our material database. And usually they are complementary to each other. Okay. Prospector, okay, it is also focused on the polymer, and is a different plan for the registry. But again, we check the database and find the material curve is still again limited in the database. Materiality, okay, and the total materials, they are more focusing on the inorganic material, and the subscription fee is quite expensive. Okay. And how is the difference between the current Moldex3D Material Hub Cloud service versus a standalone database? This will give you a short comparison table. For the user, our service is focusing on the part designer, CA engineer, modeling engineer. For the Moldex3D, is more focused on the current users. Okay, you just have this database just for simulations. And the application scenarios, this is a web cloud service. So we want this can be as a reference database for the design, for the modeling. And the purpose of Moldex3D database, it is free and equipped with Moldex3D delivery. So its main purpose is for the simulations, not for design. Okay, and this service orientation will be focused on the design. Quality index, not available for Moldex. Alternative material search, not available for Moldex. Now we can base on the more scientific way to do the similarity checking. Material recommendations, we base on the material sheet data and the data comparisons. And Moldex is not available. UI web-based versus window applications, and we can update this very quickly. And the database updates, this service will be updated quarterly, and Moldex3D is database is updated on an annual basis. Okay, and because it is not a centralized database, so once the database is updated, you need to update for each client. Data comparison. Okay, we will offer more in the future. Now is very simple, but in the future we will make this data comparison very intricate in compare with the Moldex3D. Function extensions we will quarterly update, but Moldex3D again it is just a database for simulations. So I think in the future the orientation of these two product and service will be quite different. And this products show you even more simple comparisons. This is a Moldex3D database, so it is a standalone database for each computer or for each users. And usually we update the database according to each new release. Basically, is per year. And now in Moldex Material Hub Cloud, we share the same database. However, we have some more processing of this database, and we make some new corrections of the database inside. So it is a cloud database, and we can update the database quarterly because right now we have the quality index index. So we can, according to the quality index, we can update the material. We can make some corrections. We can correct the material data according to the latest information from the material suppliers. So we can update this more quickly than the Moldex3D. And of course, after 1 year, we can make all the correction here into the Moldex3D, but you can update the Moldex3D database in a yearly basis. But if you register this service, you can update the database by a quarterly basis. And this is the current database. And we also want to develop a new database. This is we call it advanced subscriptions. And right now, in the basic subscription, we have 6,800 materials. And in the advanced subscriptions, our target is to create a new database that has 2,000 material. And this is the business opportunities for the basic subscriptions. It is a user subscription basis. So the subscription fee is 1,500 USD per year. And the early access policy, we will offer just 1,000 US dollar per year until the end of this year. So you can use in the early access special promotions. And it is very simple. User can try by himself and subscribe directly on the website. So usually user can subscribe this service directly. And for the Moldex3D users, you can persuade the current user as an extension of the built-in database because we have new functions such as material quality index, such as alternative material search functions. And also we update the database more quickly than a standalone database. So the opportunity is attached sale or bundle sales. So if you want to persuade your customers to upgrade or to pay the maintenance fee, you can add this service in the quotations. So it's a kind of a attached sale. Or you want to sell Moldex3D together with some extra services. So you can also sell this in a bundle sales. Now the discount for the VAR is 50% because this is mainly a service hosted by Moldex3D. So the VAR account is around 50%. And for the non-Moldex3D or non-CA users, I think you can use in this kind of a service to attract them to get the new contract or the new business opportunities. So the idea is to using this service as a design reference data bank. And we also offered volume discount for medium to large customers because this is the account business. So we hope you can, for the medium to large companies, you can persuade them to using the volume users. For example, when you register the account more than 5 users, you will get 20% discount. More than 10 users, you can get 30% discount for the annually subscription fee. Okay, and the next is about advanced subscription. Our plan is to offer the beta versions in October this year. And of course, the yearly subscription fee is around $4,500 per year. Basically, this is around the money you need to pay for measuring one material. So later I will see we have some material data sharing initiative for this new service. And for this database, it is a brand new database. So we will offer more completely material data. And one more thing is all the data is measured and calibrated by Moldex3D ourselves. So they are not coming just from the material suppliers. They are all measured and calibrated by Moldex3D ourselves. So we will provide all the full range viscoelastic properties, stress strength curve, digital twin corrective material data, and the injection molding validation data. All the data will have all this extra data in the database. And we also offer some advanced functions. Of course, these will include all the basic subscription services in advanced subscriptions. And we also provide some advanced functions such as material model fitting kit, material property predictor. Okay. And now we are planning to have some material data sharing initiative. This means if you subscribe the advanced subscription for 1 year, okay, you pay this money, then you can measure one material. But this is this material should be a standard materials. If you compound by yourself, or if you have some modification of the standard material, this is not available. So it's limited to the standard material, and you also want to add this material data to our database. So you join this initiative, you can measure all this data for free. Okay, so basically this is what I mean. You measure one data, you got a 1 year subscription, or you order 1 year subscriptions and you can measure one data, but the data should be open to a database. And of course you may measure more than one material data. Then we also offer the options. You can have multiple accounts for the registrations, or you have a multiple year free subscriptions for this service. Okay, this is now our ongoing measurement project. We buy the material by ourselves according to its importance in the industry, and we measure all the standard tests. So hopefully we will build the material database by our self measurement. And we also, many of your potential customers or material suppliers can join this material data sharing initiative, help us to expand this database quickly. And hopefully our target is to expand the database into 2,000 materials. Okay, this is the function we are developing now. So we will offer you the fitting tools as a web service basis, and the user can use this service to fit in their own data, and the data he can keep by himself. You don't need to open the data to us, but he can use this service in the advanced subscription. And we also have some research how to use in group contribution and the big data approach to predict the material properties. So I think this kind of the function is attractive to the material suppliers. Okay, so this is just a tentative plan. In the future, we may release these functions in the advanced subscriptions. Okay, so this is my presentation here, and next I have asked Bruce to demo the Material Hub Cloud service. Bruce, it's your turn.
Okay. Hello everyone, I'm Bruce from Material Science Research Center, and I would like to welcome you this demonstration, in which I will show you how to use the Moldex3D Material Hub Cloud service. So there are 3 service keys you should know. David just introduced them before. First is material database viewer. Second is alternative material. Third is the material selection guidance. And a good news is the material database and the service keys will be updated quarterly. Let's start to enter the Material Hub website by click the 2 links. And we suggest you can use the support browsers. And the best view shown here. So the user will receive 7-day free trial upon the registration. If the user decides to subscribe the service, their account will be extended for 1 year. So after you log in the Material Hub cloud service, this is main interface. And click here, it will show the hidden toolbar. And you can see your account information and also change your password here. And there is a service key. So you can select any one you want. So next, I will demonstrate the material database viewer in detail, step by step. Okay, and this is the main interface of material database viewer. The first step is to find the material you want to view. So you can use the 2 methods to find the material you want to view by keyword search or by polymer and the supplier search. For example, you pick one polymer type and the supplier. Here we will show the relevant material are available. Right-hand side will show its corresponding information, including quality index and analysis, and processing curve, mechanical property, and processing condition. Especially, you can select a temperature from the processing condition to mark this temperature range in the relevant processing curve. And you can also check the compatibility between them. Additionally, you can switch the different chart for the viscosity or specific balance. You can switch the viscosity versus temperature or versus shear rate. You can switch the specific balance versus temperature or versus pressure. Okay, besides overview, you can also find the material detail. This function is like the material result of Moldex3D Studio. You can view its viscosity detail or PVT. Okay, I give you a conclusion remark about the material database viewer. About the quality index analysis is based on the data source of material property and measurement method and the data compatibility. So each physical property index range from 1 to 5, and the calculation is based on a basic index plus bonus index. Okay, and this is the bonus index. By looking at the 6 physical property index, it will tell you the material file is better quality for Moldex3D Studio analysis. So next, I will demonstrate the alternate material in detail. This is the main interface of alternate material. Usually, the target material is not listed in our database. So you can use the physical property list in a plastic data sheet and to locate the alternative. I'll give you an example. This is the data sheet. I hope you can pick up the red color information into the text box, including the MFI, density, mean temperature, mole temperature, and the tensor modules. Then click the Find Alternatives button. And here we will show its relevant alternative material and similarity scores. Okay, and select one. Below we will show the physical property difference between the alternative and your set target material. You can see there each physical property difference here in this chart. If you have no idea which physical property item want to check, here we provide two examples. Example one is good for filling approximation. So it includes this physical property item. And example two is for Wabigoon approximation. So it includes the set of physical property group. So for your reference. This is for another situation. If you are lucky, the target material is listed in our database. You can directly use the search to find it out. Okay, and I pick a polymer type as HIPS, and the supplier as this. It will show relevant the material. So define a material as your target material. And here we will show its relevant alternatives and similarity. And also, click an alternative. It will show its the difference between the alternative and the target material by the similarity analysis chart. And here is a filter. You can turn on or turn off this filter. If you turn off the filter, and it will show the alternative without keep the same polymer type. But it requires longer calculation time. Okay. This region you can set up the different comparison criterion and the weightings. And the default is good for filling approximation. So this physical property check item like this. Okay, I'll give you a conclusion remark about the alternative material. The similarity is based on the difference of the two material physical property and the weight setting. If you have no idea which alternative is better, so I suggest you can pick one. Its similarity is above 90% and keep the same polymer type, like this, as the case. Finally, I will demonstrate the material selection guidance in detail. This service kit is very easy. It just consider what is your product application or what kind of your product feature has. So you can use the two category or keyword to search the recommendation materials. For example, I select aircraft application, and here we'll show the recommendation material. So pick one. Right side will show its relevant information about processing method, pressed feature, or source. That is the supplier website. So you can click the supplier website to learn the per charge information. Okay, also can switch the tab page to view the physical property. Okay, I'll give you a conclusion remark about the material selection guidance. Maybe you have some question on how do we sort out the application and the feature category. Okay, and their labels are provided by supplier. Okay, and the service just provide the label. So if you have no idea the label, you can use the label keyword into the interface of internet. Can help you to imagination on the product picture. Okay. Okay. So I hope the short demonstration can help you to understand the service case of the Material Hub. Thank you for your attention. If you have any question, maybe you can mail to this mail address.
Okay, thank you guys. That's a very very detailed introduction. So everyone have questions? Just raise your hand or leave your message to this to the discussion. So any questions, please? By far, I saw that Teresa asked questions. I think also Matt is also the questions about this advanced material hub. Is it possible to fit in the PU forming? That's a very good question. I think this advanced material hub will be released in October, and for now that it seems like currently will target for the regular thermoplastic and thermosetting material. For thermal forming, the PU forming material, that for the especially for the bubble generate, it will be out of this package. Okay.
Yeah.
Right.
Yeah. I can give some comment about this one.
Yes. Thanks.
Basically, because we want the service user can do by himself or by herself. So we want the procedure or the operation is very simple for this kind of the service. For the thermoset material fittings, usually you need to combine 2 or even more measurement data together. For example, chemorheology, you need to combine the viscosity measurement data with the kinetic data. So it's more advanced. So in our plan, we will support the more popular material and the more simple or more popular function first. So we will focus on the thermoplastic first. And of course, again, I say, in our target, we want to update the service in a quarterly basis. So if you want many requests or the service you want to add to this service, please feedback to us. We will put it in the wish list of this new service. And I promise this update speed of this new service will be much faster than Moldex3D.
Okay, thank you, David. There's another question from Matt. It's about the delivery time for the material test. I think it's for the regular material test for thermoplastic. It's regular for the 15 days, and what I mean is working days, 15 working days. But I think you probably heard that in Taiwan currently we have kind of COVID-19 problem. So the material labor, they have to work like a double shift. That we will a little bit delay for the measurement. So currently each material measurement delivery time will be adjusted. Okay, and our sales guy will reply this part and follow up each material test for you. Okay. Okay. Yeah, David, could you please? Do we have this plan?
Yeah. Of course, it's a target, but depending on the items you measured, because for the measurement, usually the operator just put the material into the machine and wait. So the most time consuming is the waiting time, because for especially for the advanced measurement. For example, if in the viscosity measurement, if you want to add the buckling corrections, then you need to measure more than 3 curves at 3 different different dies, 3 different die orifice design. So the combination will be very huge, and each measurement will take time. So in our experience, for each properties is around take 1 day to do the measurement. So if the material you will measure 3 properties or 5 properties, I think 1 week is very reasonable. Yeah, and now we have 50 days. I think it's related to the lead time issues. Also, this is related to our available manpower and the available working time, because now Taiwan we have divided our employee into 2 streams because of the COVID-19. So the performance will be reduced, but our target is still continue to improve the performance of the data measurement.
Thank you, David.
Yeah.
There's another question from Carlos. Is any plan that we can connect ISLM and together with hub, material hub?
Okay, the current answer is no, because ISLM is a private cloud and ISLM is a public cloud. So usually, but our plan is you can download the data file from the material hub, and then you can management this download data. You can upload this data to your ISM systems for the management. I think that's a more reasonable way to use it. At least we offer another cloud service for the ISM. Then I think we can share the same account to interface in this data. At this moment, we have this kind of plan. So the answer is no. Yeah,
Okay.
but you can download data and import into the ISM for the management.
Okay, thank you, David.
Yes.
And Marcus, please.
Yeah, thank you first for the presentation. Hope you can hear me.
Yeah.
Yes.
Yeah. So, just to be clear, what's going to happen to the material database that is in Moldex3D right now in comparison to the material hub? Will material still be added there?
Sorry, I cannot get your point.
Yeah, so for the old material database that's
Yes.
within Moldex3D and the
Yes.
material wizard, will
Yeah.
new materials still be added to the material database?
Yes.
So what would, like, database-wise, what would be the difference with just having the regular material database to the basic subscription? Do you still get the same materials within both, or?
Okay. Basically, right now in the basic subscriptions, the database is the same. but
Okay.
we will update the cloud service data more quickly than Moldex3D standalone. Yeah.
But they will, like, long term, they will still disregarding for the quicker updates, they will contain the same data.
Yes. Per year for the new release of the
Yeah.
Moldex3D, we will update the database with the latest version of the Material Hub. In the
Okay, yeah,
basic.
then I understand. So basic is basically an extension of the old material database and with a significantly better user experience and some other functionality. Yeah,
Yes,
okay.
and the orientation is more focused on the non-Moldex users, I have to say.
Yeah, okay. Yeah. And so what will be the criteria or requirements for materials to be categorized as in the basic database or the advanced database? You mentioned that materials that are in the advanced database has to be tested by Moldex3D labs. But will that mean that materials that you test yourself will never end up in the basic database, or?
I think in the basic database, many of the data, I think Moldex3D, I think we in the current database, we measure around 3,000 material. Okay, only half of the material, and many of the data comes from the material supplier, or comes from the literature. Okay, so or comes from the conversion of the other material data. So I think this kind of the data is not so reliable from viewpoint of the simulations. So we want to create a new data sharing initiative, because we want to measure the data by ourselves. We control everything, and we can equip with the measurement with our latest approach or the simulation, like the digital twin corrections, and we can guarantee the quality of the measured data is better than the current material data. But we need to do the distinguish between these two databases. So we will using this new database as the extra advanced service. Yeah, not for the current Moldex3D.
All the materials in the advanced database will be, as you said, those that are you have full results for them, not only maybe what the customer requested.
Yeah.
Okay. Yeah.
And of course, if the new measured data already existing in the current database, we will update the data, but just limited to the current data, not for the advanced data such as the physical elasticity or the other extra data. Okay.
Okay. Thank you, David.
Thank you very much.
Thank you, Marcus. Okay, so we have another question. Is about that it's easier to get our competitor material file, but to compare to the Moldex3D material file, it's a little bit hard to get. So what is our strategy to get more material into Moldex3D material file format for from the supplier, or to deliver to supplier, or to deliver to our customer? So David, do you have any comment about this?
Yeah, I think right now we already have established good relationship with the many material suppliers, and we will continue to enhance this kind of the relationship. And right now we have this kind of the service, and we also thinking about how we can sharing this kind of the service to the material suppliers. Maybe we can come up with some win-win solutions with the material supplier, because we are their friends, not their enemy. So I think we will strong the partnership relationship with this material supplier, and in the future we will offer them maybe some special tool to convert their measurement data into Moldex3D format, or we will provide them more attractive policies for data measurement. I think in this way we can have more and more material supplier will support our data format, and in the futures we hope we can expand this database very quickly. And of course, only the material supplier will do this if they undergo the pressure from their users. So sometimes we also persuade our users to have some pressures on the material suppliers, asking them not to only support the Morphflow UDP file, but also support Moldex material file. So this will be more easy way to do this. So I think another point we want to develop the material fitting kit is we want to provide this fitting kit tool to the material suppliers. So in the future, they are more easy to fit in the material data they measured and expose into Moldex3D data file. This is our target. Yeah.
Okay, thank you, David. Okay, so I think this is everything from this webinar, and also we will prepare the public document for everyone that you can use it to discuss with Moldex3D customer or prospect about this